everyone, I am Intan Nusyaira binti Mak Zahid. In this video, we will show you on how to run a simulation for force and motion and coefficient of static friction. So for now, I will show you a simulation for force and motion. In this experiment, what we want to observe is a friction properties when box not in motion, when box in motion, and when 100 kg box in motion. Once we open this page, we will see this picture in this video here. So what we need to do is tick all this box to show the value that we need to measure. So for now, we have box here with mass 50 kg and set this friction to halfway. Apply force 50 Newton on this box and we can see that static friction force is 50 Newton to the left and applied force is 50 Newton to the right, and for the sum of force is equal to 0. Next, we increase the applied force to 150 Newton. Then we can see that the box immediately start moving. When this box in motion, the maximum friction force is 94 Newton to the left and the applied force is 150 Newton to the right. Also, sum of force is equal to 56 Newton. Okay, then we start over. We place a second box on this box, then carefully increase this applied force until the box start moving. So we can see that the maximum friction force is 188 Newton to the left. And for the magnitude of applied force, we slowly reduce the applied force until the box have constant speed. So we can see here, the box is in constant speed and the applied force is 188 Newton to the right. Next, increase the applied force to 500 Newton. Then remove back the applied force to 0 Newton and immediately reduce surface friction to none. What happened here is the box is still moving when there's no applied force on it. Then we increase surface friction to large and we can see that the box instantly stopped moving. In this part, we can conclude that when there is no friction, the effect on the box movement is constant, while when the friction increases, the effect on the box movement slowly decreases and stop at some point due to the friction. That's all for me and we continue to part B.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahri bin Muhammad Zahri and I will show you how to do the part B on the simulation. First of all, you have to, for the table B1, you have to do the angle, you have to set the angle to 0 degree and the Woods box, the coefficient of Woods box on wood surface is 0.25. And let's see, we already set it 0 degree and the coefficient of friction 0.25. After that, we run it. We have to adjust the mass of M1 at this using this point, and we will see if we set the mass of M1 3.1 kg, the box move towards M1 in 0.45 ms squared, but we have to adjust it until the M2 barely move towards M1. So we have to adjust it, and we see with the mass of M1 2.6 kg, the acceleration was 0.08 ms squared, and we see the M2 move toward M1 slowly. After that, we pause it, and then we do the same, but we change the weight of M2 according to the values given. This is the values given. Let's see 8 kg. Alright, and then we run it. So this acceleration was 0.055, but we have to adjust it until the box move slowly. So in the lab sheet, it was 2.1. Then we set it until 2.1 and we see it moved in 0.1 ms squared acceleration. Then we move next to the table B2. The table B2, it use same material which have same coefficient of friction but with different angle, and the angle was 30 degree, and we have already set it 30 degree. And then let's say we use 6 kilogram of M2 and adjust it at 6 kilogram, and we do the same with table M1. We adjust it, and for not waste our time, we just see the readings that we have done previously, which is for 6 kilogram, the load on a hanger M1 was 4.4. Okay, let's see. 4.4. 4.4. Then we see the box move towards M1 slowly with 0.1 ms squared of acceleration. And then we repeat the step with different values of M2. We just follow the values given. And as we see, the mass M1 was lower than M2. And then we go towards table B3. Okay, let's say we use 6 or so. Then we set 0. But the coefficient of friction was 1, which is maximum. Then we run it. And for 6, it should be 6.1 kilogram. Let's see. And then we got the reading 6.1 kilogram. It's same as for table B4. We set it to 30 degree, and then we set it to 30 degree, and then we adjust the M1 so that the M2 move towards, barely move towards M1. So as we got the reading, just move on to the reading. For the table B1 and table B2, it shows the reading of M1 was lower than M2. And then we have seen that there is some reading that cannot be recorded because of the limitation on the simulation. And for the table B3, we see that the increment just larger by 0.1 increment. And then that's all for me. Thank